In this video, we are going to build a game and achievements API using GraphQL, which is a query language for APIs, where a client can specify exactly what they need from each request. And if you take a look here, we are going to be working with two different entities, game and achievement, where we have a one-to-many relationship. So one game can have 0 to many achievements. And simply for our example, our game is going to have, of course, the ID, name and genre. And the achievement is going to have a title, the difficulty, which is going to be an enum. We have some points, which is an integer, and the game ID, which specifies which game this achievement belongs to. Now, if we were to implement this in the traditional REST API manner, we would typically have a lot of endpoints that we can call, each specific to a certain resource, for example, games, achievements, and so on. And of course, we would have some HTTP methods for each, such as get, post, put, delete, and so on, to specify the CRUD operation that you are trying to perform. So normally, in an application similar to this, we would have get/games, which would return an array of games, get/game/id, which would return more details, but this time on a specific game, and we could have something like game/id/achievements, which would return the list of achievements for a specific game. Now here's the problem. Let's say a client needed to get the list of games and show the list of achievements of each. They would need to first call get/games, which would return the basic game information, such as ID, name, and genre for each game. But then they would also need to make different network calls for each game to get the achievements of that specific game. They would need to make a lot of network calls, that's from one side, and from the other side they would need to get all those different results and then map them to the correct games and so on to show them on their screen. Now you could argue that to fix this issue we could maybe aggregate and return that achievements data inside of the games listing API, so we could make a lookup and then return that data, but that's a very bad practice. We shouldn't usually return all the data in the listing APIs. That's why we would have game/id and then game/whatever. Now we could also argue that maybe we can go ahead and create a specific endpoint that returns all the games and all their aggregated data, for example /game/aggregated, but that only covers one use case. What if we had more clients with more different use cases? We're not going to create more endpoints for each specific use case and so on. So here I want to highlight the problem, which is underfetching, overfetching, and a lot of network calls. Overfetching basically means when a certain endpoint returns more data than you need. Underfetching is when a specific endpoint returns less data than you actually need, so you would need to make more network calls and so on. And here is where GraphQL comes into play. In GraphQL, we only have one endpoint, /GraphQL, which is of type post. And if you take a look at this GraphQL schema, we can see some keywords, for example, type query, type mutation. Let's ignore game for now. Query and mutation are two root level operation types that you can perform in GraphQL. They come by default. We have a third type called subscription, but we're not going to be talking about it. But basically, query is used whenever you want to fetch data, and mutations are used whenever you want to write data, whether it's creating, updating, or deleting. And if you take a look inside of each of these, for example, inside of query we have games, game, and achievements. Those different fields are considered entry points that retrieve different types of data. For example, games returns an array of game. Now game here doesn't exist by default in GraphQL. It's not a default type or a primitive type like integer, float, and so on. So we have to create that type, which is why we have type game here with those different fields, ID, name, genre, and achievements. Those are using default types such as ID and string. And here we can see that we have achievements. So we can also query achievements whenever we are returning a game object. Now, usually every entity that you have, or every domain object, let's say, that you have, it's not specifically entity, but every domain object that you have will usually be represented by a custom type that you create because you want to interact with that type. Now, if you take a look at mutations as well, we also have some fields that are entry points for some write operations that you can perform. For example, create game, which takes an input and then returns a game. Update game, create achievement, and so on. Now, the good thing with GraphQL is that let's say we have different clients consuming our API, for example, a mobile app and a website, for example. Both should call /GraphQL for any operation that they are trying to perform because we only have one endpoint. And here they can specify which operation they want to perform. If it's querying the games, for example, they would specify the query type, for example, query, and then they would specify the field name, for example, game, which would return a specific game by ID. So here they specify they want the game with ID 1, and here is the power of GraphQL. You can specify which fields you want to return, for example, name and genre. The website might want to also show the achievements in the detailed page for one game. They wrote the same query with one little twist, which is they added this achievements field here, and this is inside of game here. So achievement would have its own type and its own fields. So achievements, for example, has title and points, so we can also query them. And this specific query, whenever it's executed, it is going to return the game of ID 1 with the name, genre, and achievements, and it will only show title and points for the achievements. You can also query difficulty, for example, by adding it in this query. We will see more of this now that we get started. But here we can see that the client can explicitly decide what they want to see, which fields and so on. So we avoid overfetching, underfetching, and unnecessary network calls. I went ahead and created a normal NestJS application. I removed the app service and app controller files. And the first step is to install those different packages: NestJS/GraphQL, NestJS/Apollo, Apollo/server, and GraphQL. This is if you are using Express with Apollo, Apollo being the driver that you use. Now, if you want to use Fastify with Apollo, you would install those. And for Fastify and Mercurius, you would go ahead and use those. But let's go with the default option of Express and Apollo. Now we can simply register this GraphQL module in the imports array, and the for root method can also take a type. So we specify the Apollo driver config from NestJS/Apollo, and for the driver we selected the Apollo driver. Of course, we can see that we have a lot of different configuration options here. And here I set this playground option to true, which will give us a user-friendly interface that will help us build our queries faster. In NestJS, we have two different options, either the schema-first approach or the code-first approach. Schema-first approach means that we have to write this schema ourselves, the game, the fields here, type query, and all of that. And this is language agnostic, so this schema would work with any programming language using GraphQL, any framework. It's not really specific to any language. And the code-first approach, where we write the code, and this schema would automatically be generated by NestJS. So all we would have to do is use some decorators with TypeScript to generate those different things. Now let's go ahead and use the code-first approach, since most people use that method. Now, since we have two different domain objects here, game and achievement, let's go ahead and create two different modules for them. So just like we usually do, nest generate resource games to create a module with the service and the controller and so on. But this time, we're not going to select REST API. We're going to go ahead and select GraphQL code first. I'm going to say no for that because we want to generate the entry points manually. So now we got this games folder with games module, resolver, and service. Everything sounds familiar except resolver. We are used to having games controller here with this controller, with a controller's decorator. Now, in the world of GraphQL, we use resolvers to resolve the different fields that we have here into the data shape that we usually request. So in NestJS, when we want to handle those different fields here to return the data, we would use resolvers. Just like in REST API, we would use controllers with route handlers. And inside of resolvers, we can actually use @query from NestJS/GraphQL and @mutation to specify our different queries and mutations that we have. So here, for example, we could have get games, which could talk to a service, for example, the game service, to return the list of games. First, let's go ahead and create this object type for GraphQL, the game. Since we are in code-first approach, we're going to create a TypeScript class. So let's go ahead. And here inside of games, I created a types folder. And let's just create game.type.ts. And here we should use @object_type, which is from NestJS/GraphQL, to specify that this specific class, for example, let's call it game, this is our own custom object type. Now let's go ahead and create those different fields. So to specify a field, we should use the field decorator. And here, let's say we have a name, for example, which is of type string. String here is recognized by GraphQL because GraphQL basically has float, ID, string, int, and boolean. So if you have boolean or string, this will be automatically detected by GraphQL. However, if you have a number, so if this was a number, we would have to specify what type of number this is, because GraphQL does not know what a number is. It just knows float and integer. So here we would need to pass in this type function here to specify what kind of scalar type, it's called scalar in GraphQL, it refers to. But since it's a string, we don't really need to do that. I went ahead and created this class. I added ID and genre. So this is now how this looks. And of course, this schema has not yet been generated. So to be able to generate that, we should do one more thing. So in app module here, we can go ahead and say auto schema file. And here we could either say true, and then NestJS would automatically save this in memory, or we could actually give it a path. And yeah, let's go ahead and run our server now. Okay, now if we take a look, we got an error saying that if you are using the code first approach, then we should explicitly provide a return type for our function. So here, for example, this query, we don't really know what it returns yet. Now that we have this game type, we should specify that this specific query here should return an array of games. So let's say game, and then here we should specify that it's an array. Now let's go ahead and just return an empty array for now. Let's save. And as you can see, the error is now gone. By the way, I had an issue with the path. Now I fixed it. So after rerunning, we can see that it actually automatically generated this SDL for us. So type, game, ID, name, and genre. And here the exclamation mark just means that this is a required field. So actually we could make it nullable. Maybe a game does not have a genre, for example, selected. So to do that, we can specify some options here. So if you take a look, we have many options. If we set nullable to true, and now if we save again, if we go back to our schema, it updated it automatically. It doesn't have this exclamation mark, meaning this is an optional field now. Just like we have nullable, we can also use other options, such as, for example, description. If we save, if we go back here, we can see that we now have this description right here. Now, if you remember, we set this playground option to true. So now if we open the browser on localhost 3000/GraphQL, we can actually open this UI where we have some docs. We can see that we have under the query section, we only have one query for now called getGames, which has the game type as a return type, which has those different fields. Genre has this description here that we have set. And you can also see the schema here, which is the same one that was auto-generated here. So we have the type game, the description, and under queries, we have getGames. So here, if you want to execute this, first of all, we should specify the type, which is a query, not a mutation. And then here, we should also use the same name, so getGames. And then here, we could specify what different fields should be returned. So for example, ID. Now, if you hit send, we only get an empty array because currently our resolver is just returning this, but we're gonna actually be using a database in a second. And if you notice, this getGames name is the same name that we assigned to our query handler here, which is getGames, the method name. However, we can actually override this by passing an option of name here. So we could say, for example, games. So now if we save, first of all, we can see that this is called games now under query instead of getGames. And if we refresh here, if we open this up, as you can see, we also have games here. So now if we have getGames and I try to run, I'm gonna get an error. Cannot query field getGames on type query. Did you mean games? So now I should rename it to games. If I hit send, we got this response back. If you notice in the response, we have a data key, which is added automatically in GraphQL. This is the standard. And then here we have the field name, which is games. Now, to make things more interesting, I created this mongoose schema. Of course, you could have a type ORM entity here. It doesn't matter. It doesn't change anything. But basically, I created this schema. We have name and genre. And I also went ahead and registered mongoose, of course. Here you would register type ORM if you're using type ORM. And this doesn't matter. You could be using SQL, no SQL. It doesn't really depend on the database that you're using. This is just to show you a better example. So I went ahead and created the schema. And now inside of service, I went ahead and injected this model so that we can actually return some data from the database. And now the resolver, instead of just returning an empty array, is going to use this game service and call this getGames method, which will find all the documents in our MongoDB. I've created some games here, just to use as an example. And now if we go back to the query here, and now we're gonna execute games, and we are gonna return ID and name. Also, as you can see, the tool is helping me with the different properties that exist on the type game, which is the return type for this games field, which is a query. Now if you hit send, as you can see, we actually got the list of different games. Now if you wanted to actually also add the genre, we could do that and hit send. And as you can see, we also now got the genre. Now I don't really like this default playground because as you can see, it's very buggy. So what we could do instead is add a plugin here, Apollo server plugin landing page local default from this import from the Apollo server package. And don't forget to set playground to false. And now if we run our server again, we're gonna get this new UI. If you take a look here on the left side, we can see we have this root, which is the root type, where we would have the root types such as query and mutation. And if you click on query, we should be able to see the fields that act as an entry point for our different operations, such as games, game, and achievements in this case. Here we just have games for now with this game object type as a return type. If we press on it, we can see that we can press here to add things to query or press to remove them from the query. For example, now we only selected name in the games. If you execute this, we can see that we only got the name this time in the response. Now we said that the purpose here is to also be able to return achievements whenever needed inside of game. However, now our game type object doesn't really have an achievements array now. And if you go back to our code, if you take a look at the game type that we created, we don't really have an achievement here. And this is because we haven't created the achievements module. So let's go ahead and do that now. So I'm going to create another module or another resource with the name achievements. And of course, GraphQL code first approach again. I'm going to set no here. And now we got this achievements resource created with its own resolver and service. I added some stuff here. So I added a schema for my MongoDB for the achievement. It has a title, description, the difficulty enum, the points, and the game ID, which is what is going to be pointing at the game here. So basically this is the schema that we've created. And I also went ahead and created this type. Basically, to take a look at the type, again we need to use object type because we need to mark this as a GraphQL type, just like we did with game here. And I passed some fields, so ID, title, those are strings. For points, for example, if you remember, we said that GraphQL doesn't have a default scalar type of number. It doesn't know what that is. It has integer and float. So here we would need to specify what kind of number this is. So here we said integer. And for difficulty, this is an enum. Now by default, to be able to use enums with GraphQL in NestJS, it's not enough to actually create an enum and just use it. But whenever we have an enum that needs to be used, we need to register it with GraphQL. So here we should call this register enum type and then pass in the enum that we have and give it a name that should be used by GraphQL. And we could also pass in an optional description here. So this is our achievement type now. And now to be able to query it and get it in the game's response, all we have to do is just create a new field here. And then this field, let's call it achievements, for example. And here we're gonna give it the type achievement that we have created. So basically this object type here. And then this is not enough. We should also go ahead and specify the type and set it to achievement here. And since this is an array, let's go ahead and set it as 1. And now if we save, if we take a look at our schema here now, we can see that the type game now also has this achievement fields, which points to another achievements array. And if you take a look at the achievement type, we have all those fields that we can also query. I went ahead and added some achievements in my database, and I pointed them at different games that we have here. So they all have game IDs that are valid. And now if we refresh here, if we open game, we can see that now we can also return the achievements. But again, achievements should also return some fields here. We should also specify the fields here because achievements is a type as well. So here, for example, if you press an achievement, you can see that we have description, difficulty ID. Let's select ID and title, for example, and hit example query. Now we're gonna get an error here, which is cannot return null for non-nullable field game.achievements. And that's because we're not actually resolving this achievement field, which means that this getGames that returns a response to this resolver that gets sent back to the client doesn't have an achievement. And that's correct. If you go here in games, we're not storing achievements. We have ID, genre, and name. So NestJS cannot automatically know how to fetch those achievements. We should write code for that. We should actually write code that will group or grab the required achievements and return them with the games. So how can we actually do that? Well, in Resolver, if you go back to Games Resolver, just like we have query and mutation, we also have a decorator called resolve field. And here let's specify that this should return achievement array. And let's call it achievements. And here, this take a parent from NestJS GraphQL. And basically, this specifies the parent to which this achievements is a subchild of. So to better understand this, let's open our schema again. We are trying to resolve this achievements field. The parent of this achievement field is the game that is being returned. Because if we take a look here, games return a game. Inside of a game, we have achievement. So the parent is game. And in order for that to work, inside of the resolver decorator here, we should go ahead and specify the parent. So here we could say, for example, game, because this is the game resolver. And now with this in place, we can actually have access to the game here, which is the parent. And here we can actually, for now, let's just log game.id. And here let's specify that this is a game. And for now, let's just return an empty array, meaning we do have achievements. It's not null, it's an empty array. And by the way, we got this nullable error because here achievements is required. However, if we actually added nullable to true, it would have been fine if we got null. But in our case, no, we shouldn't get null, we should get an empty array if we don't have any achievements. But our error was that we forgot to actually resolve that field. So now let's see what happens. If you go back here and call this, as you can see, we got empty achievements, empty arrays, and the query ran. If you go back here, we can see that this resolve field was actually triggered 4 times. So for each game, okay, to fetch the achievements or to resolve the achievements for each game, we have 4 games. Each achievement field here triggered this resolve field method. All of this is happening in one network call, so in one request, but this request can trigger this resolve field method multiple times for each game. And we can see that we got the correct game ID for each time. So here we could actually call a method that is going to query our achievements collection and return the different achievements for each game ID. So inside of the achievement service, I went ahead and injected the achievement model. That way we can access the achievements collection in our database. And I created a method called getAchievementsByGameID, which takes the game ID as a parameter and then returns the list of achievements that belong to this game. Let's go to achievements module, and then here let's add this to our exports. And now in our games module, I'm going to import the achievements module. That way now inside of our resolver here, inside of the games resolver, we can go ahead and add the achievement service and use it as a dependency. And now let's go ahead and instead of returning an empty array, call this .achievement service .achievements_by_game_id, and here we can pass in the game.id. Again, the parent decorator here specifies the parent to which this achievements field belongs to. So in this case, getGames should return a game, and inside of game we have this achievements. So game is the parent, and achievements is what is being resolved. And to resolve that field, we should add this resolve field, because when we are querying our database here in getGames, we are not actually storing the achievements, so we will need to separately fetch this data or do a lookup or whatever. And this is actually pretty nice, because now if a client doesn't really care about achievements this piece of code will not be executed. So we wouldn't actually go ahead and query our database again to get the achievements. So this is now on demand. Here this should be game ID, not ID. New mongoose.types.object ID. And now if you hit send, as you can see, we now got the array of achievements for each game. Of course, we specified that we wanted ID and title. We could go ahead and say we also want the description. If you hit send now, as you can see, we also got the description. We can say that we don't want the achievement now. If you remove this, hit send, we don't get the achievement, and this part of the code does not get executed. Now let's complete our queries inside of the games resolver by adding this game field that should resolve and return a game and takes an argument to see how we can actually pass in arguments. So I created a second method called getGameById, which is also decorated by @query, which returns a game, and we don't want the field name to be getGameById, so I specified a name called game. And when we save, as we can see in the schema.graphql, we have a second field inside type query, which is game. Now we still need to add the argument. So in NestJS it's pretty simple. We can say @args, and then here we can specify the argument name, for example ID, and ID is a string, so we can simply say ID string. Now of course here we would have a method, for example gameService.getGameById. Let's go ahead and create this. So in the game service, I went ahead and made this getGameById method, which takes an ID and then queries the database to find this by ID. And this is pretty much it. And now, as you can see inside the query, we have two different fields, games and game. I'm gonna remove games for now and just execute game, which takes an ID. Now here it went ahead and added a variable, game ID, so that we can separately specify it here. But of course, we could have just said, for example, 2 here, or actually it should be a string, but you get my point. Let's try to get this game, Fantasy RPG. So let's take the ID and then here set it to this one, and here we should of course specify the fields that we want to return. I'm gonna say I want the name of this game and the achievements for this game, and for the achievements I want the ID, title and difficulty. Let's hit execute, and then here as you can see we got a response. We have the game name, and of course here we have one game. It's not the games anymore, we're executing game. And as you can see, the achievements have ID, title and difficulty. Those are the 3 fields that we specified inside of achievements. Normally, whenever we are listing resources, we don't actually find or fetch all the data. We should use pagination. So just like we used argument here to fetch by ID, we can also pass in arguments here. So let's call this, for example, offset, and this should be offset, but here this should be a number. Again, GraphQL does not know what a number is, so we should specify here the type as an option, and here we would say, for example, int. And actually this should take a method that returns int, not just int. Of course, we can pass in another argument as well. We can pass in many other arguments. So let's say limit now, and then here this is going to be called limit. Let's save this for now. And if you go to the schema here, we can see that game now can take 2 different arguments, offset, integer, and then limit. And of course here as well, if we refresh, if we open games, for example, we can see that we can pass in an offset and a limit. So I added those 2 arguments in my service, limit and offset, and here after finding we would skip and then limit. That way we only query limited data. Let's open this and refresh. And now let's say for the games we just want the ID and the name, and here of course we don't have the game ID anymore. We only have offset and limit. So let's say offset 0, we don't want to skip anything, and we just want to return 3 games. If we hit on send, we got the first 3 games. If we take a look at our database, Adventure Quest, Fantasy RPG and Legends Unleashed. Now if we wanted to skip, let's say, the first game, so I'm skipping Adventure Quest. If we hit send, as you can see, this time we got Mystic Realms, Legends Unleashed and God of War. Now a game might have hundreds of achievements or thousands of achievements, so querying all of the achievements might be heavy. What you could also do is pass arguments to the fields that we have here, not just to the main root field that is an entry point for some query operation and so on. We could also add it to some fields inside of it. So just like inside of the getGames method handler here, we have offset and limit that are arguments. For the resolve field that returns or resolves the achievements, okay, we can also add those arguments. Now, it becomes a bit ugly when we have a lot of arguments here. So what if we had some filtering maybe? So for example, let's assume we have a filter on the enum, which is the difficulty. As you can see, this gets ugly. So instead what we could do is, let's go ahead and inside of games, let's create a folder and call it args. And let's just say, for example, achievements.args.ts. And here, just like we have this object type for our different objects, for the arguments that we send to our queries, we can also say args type. So here we can just create this class achievements args, and now let's move those. Let's remove them from here. So we would have something like this, achievement args with the args type decorator, and we would have those three different arguments, offset, limit, and difficulty. Let's assume that we're not forced to actually filter by difficulty, so let's add this as nullable, and let's just force the user to send an offset and a limit for the different achievements. Now let's go back to our resolver, and here we're gonna say at args, and then here let's just say args of type achievement args. And just like that, if you go back to the schema and we refresh, inside of achievement, not only do we have the fields that can be returned, like for example description and difficulty, but you can also add offset, limit, and difficulty. And here you can see that limit and offset have this interrogation mark, meaning this is required, but difficulty doesn't have it, meaning it's an optional field. And as well, it created those different variables, but of course we could send them right away. So offset 3, for example, skip the first 3 and then limit it to 5 results and so on. But it's always cleaner to use variables like that. Now, of course, this wouldn't work because currently our get achievements by game returned all the different achievements for a specific game. It doesn't use skip and limit. So let's go ahead here and let's add some, let's say args here, or you can call it anything you want. And I'm gonna pass in the achievement args. So here what I'm gonna do is, instead of having this, I'm gonna create a match. Again, this is specific to your database. So in Postgres you would do something else, but here I'm just gonna have a match with this. So by default we're gonna match by game ID. However, if we have args.difficulty, then we would also modify this match and filter the difficulty field. So we end up with this. By default, we're gonna match the achievements by game ID. If we have a difficulty, we're gonna also match by difficulty or filter by difficulty. And then of course we have the skip and the limit because we don't wanna return all the achievements from the database for a specific game. This is pretty much it. Let's see what happens now. Of course, here we would need to send the args. Let's save. So let's start from scratch. For the games, we want to not skip anything. So we're gonna start from the first game, and then we're just gonna return the first 3 games. Now, inside of game, we care about, let's say, name and achievements. Now, inside of achievements, we just want to see maybe the ID, and I'm gonna put the title and difficulty to prove that the difficulty filter is working. And now let's add some arguments, for example. So for the achievements offset, I'm not gonna skip anything, and I just want to show one achievement. I'm not gonna add the difficulty filter now. So let's hit on send, and as you can see, every game only returns one achievement, even though it has more. Now here, the first achievement is easy. The first one here is medium for the second game, and for Legends Unleashed, it's also medium. Let's say that we want to filter by difficulty, and then here we just want to have the hard achievements. Let's run this, and as you can see, now we just got one hard achievement in each. Let's say we want to limit it to 10 achievements. Hit send. Okay, those achievements don't have more than one hard achievement. Let's say we wanted the easy achievements. Let's say execute. They also have one. Let's say medium, execute. Okay, as you can see now, for example, the last game has two different achievements with the difficulty medium, and we only get the medium difficulty. However, if we were to remove the difficulty filter and hit on send, as you can see now, we got all the different achievements, or actually the first 10 achievements for each game. Now, in most applications, you're going to be using offset and limit a lot, or the paginations a lot. So what we could do is create a separate args type, and then here let's call it, for example, pagination args. And then what we could do is actually extend this class. So here we could say extends pagination args. And now achievement args has offset limit and difficulty. And we can reuse this pagination args anywhere in our app by extending pagination args. So it would be a good idea, for example, to create a common folder here. And now I moved this pagination args inside of the common args folder, and we can use it anywhere in our app by extending it and adding extra arguments if needed. So far, inside of root types, we only have query, although we said that we can also have mutation to write data, such as maybe modifying, updating, creating, deleting, and so on. So let's see how we can have a create game operation as a mutation. To get started, inside the game's resolver, just like we have this query decorator, we also have a mutation decorator. And here I specify that this mutation is going to return a game object type, which is basically the newly created game. And here the method is called create game. Now, we could keep it that way, or we could also override it just to follow our own convention. So I'm just gonna keep it create game. And then here we should call a method that takes the game input to be created. And just like we can use the args decorator to get some arguments, we should do the same for mutations. So we also use the @args decorator. Now let's say we have a field called input, which is going to have the create game input object. Now to create inputs, just like we have object type, we also have an input type. So let's see how we can actually create that. Just to be clean, I'm just gonna create a new folder inside of games. I'm gonna call it input. And then here I'm gonna create a file. I'm gonna call it create game.input.ts. And you just create a class and you decorate it with @input type. And also you use the field decorator on each field that should be sent. And this is pretty much it. Now in game resolver, we should go ahead and send the input for the create game. Of course, here we should make the import. Now this is complaining because we haven't created this method yet, so we need to create it. But before doing that, I want to show you that now inside of our schema here, we have this type mutation with this create game field, which returns a game. And if you go back here as well, we only had query, but now we also have mutation. If you press on it, we can see that we have this field create game. So we can now execute this create game operation to create games in our app. I went ahead and inside of game service, I created this method create game, which takes the game input and then goes ahead and creates a new document in our database. Now let's go back here and I'm gonna remove everything. I'm gonna press on create game. As you can see now, the operation type is mutation and not query. And here we should call it something. It could be anything, by the way, this. But here, the operation name or the field here on the root level inside of the mutation should be the same that we have here as a mutation. So it should be create game or it will throw an error. And create game takes an input just like we said. Let's clean this up here as well. Now, the input, as we know, it should be genre and name. So let's press on genre and name here. Let's say CSGO, for example, and the genre, let's just say first person shooter. And here we should specify the fields that should be returned in the response. So, okay, now we set the input fields here. Let's go back to create game. Now let's just say we just want the ID of the newly created game. We don't care about anything else. Let's go ahead and press send. And as you can see, we got this newly created game ID. Now let's go ahead. I'm going to remove everything here. Open the queries. I'm going to open game by ID. And now the ID I want is this one for the newly created game. And I'm going to open I want to request the ID, the name, the genre, and the achievements. And for the achievements, I want to set the limit to 5. And we want the ID and title for each achievement. Let's hit send. And as you can see, we got the newly created game. So CSGO, genre is FPS. We don't have any achievements. And if you go back to our database and refresh, as you can see, we got this newly created game. Now, let's go ahead and maybe create achievement mutation inside of the achievements resolver, and I think that would be enough examples for today. So inside the achievements resolver, let's go ahead and create a mutation. This mutation is going to return an achievement, and then let's just say create achievement, and here of course it should take some arguments, which is going to be the input for this method, and then here we could just say input, and we would need to create the create achievement input class, and then here we should call some method on the achievement service to actually create the achievement, and here this should be create achievement. And again, if you don't specify a name, it's going to get this create achievement name. Let's go ahead and create this input type. So in achievements, I'm going to create a types folder, an inputs folder. And then inside of inputs, I'm going to create a new file, create achievement.input.ts. So our create achievement input class is going to look something like this. Of course, we have @input type, and then every field should be decorated with @field. The number here should actually specify an int, so that GraphQL understands this scalar type, and this should be fine. And of course, in resolver, we made the import, and now for create achievement, we need to pass in the input, and let's go ahead and create this method. We previously had get achievements by game ID to resolve the field inside of game resolver, just as a reminder. But now let's go ahead and create this method. So the create achievement method is going to look something like this. It takes the create achievement input, and then first of all, we're going to make sure that the game exists. If it doesn't, we're going to throw an error. And then if everything is fine, we are going to go ahead and create this new achievement, of course, with this game ID, and then save the document in our database. Let's see if this is working. First of all, let's go ahead, refresh here. And now if we go back to the root, if we check our mutations, you can see that we now have a create achievement mutation. And if we open it, we can see what it takes here. First of all, let's select it. So now we can see that it's auto-generated. And let's say that we just want the ID of the newly created achievement and maybe the title. And in the input, let's just go ahead and add all those fields. So I filled some of the information. I set the title as sharpshooter. It gives you 100 points. The game ID is the one for CSGO, which is the newly created game. For the difficulty, I want to show you that when you open this, it will give you the enum types. Let's say this is hard. And then the description, for example, achieve a 90% accuracy rate. Now, if you go ahead and create this achievement, as you can see, it was successfully created. And now that we've created this achievement, let's go to the queries and query a single game by ID. And this time, let's set this ID. So here, let's first of all remove this input. We don't need it. And for the game ID, let's select the game, which is the ID of CSGO. And here, let's just return the achievements and the title of the game, the title of the achievement, and maybe the description. Of course, we have to pass the offset and limit. So let's do that. And if we press on query, as you can see now, our game, and just to see the game name to make it better, I'm gonna add the name. If we run again, as you can see, CSGO now has one achievement in its array, which is sharpshooter with this description that we just created. And of course, in our database, if we refresh, as you can see now, we got 12 different documents, this one belonging to CSGO. And this is so beautiful that we can actually decide which fields we actually want. Because, you know, achievements does not exist inside of games, inside of our database. It's a separate collection, and we don't have to always query it. It's on demand. So this really shows you how you can avoid overfetching and underfetching, and how you can give the freedom to your clients to actually request exactly what they need. So this was it, guys. I hope this video was helpful to you. Please make sure to leave a like, subscribe, share it with your friends, and if you have any questions, please let me know. Thank you, and I will see you next time.